All right, I want you guys to write on top of these notes that today we're doing 4.2, which is all about slope and rate of change. Today is 12/1 because it's December, and it looks like it. I know, you think it could have waited one more day. Huh? Oh. I was hoping like 8 inches would dump like last night. Oh yeah? How much? All right. Everybody's taking notes. Everybody's writing this down. Kaden, you got your stuff open? You got your notes done? Started? Nice. Does it say this on top? Keep him on top of it, okay? Yep. Part of being a partner. All right, let's begin. So, the first example I want to do, did you guys do rate of change and slope with Mr. Olson? Yeah. Yes. All right, example 1. Let's say I have a graph and it looks like this. And I'm going to graph one point, which is going to be -3, 4. Everybody writes it. And the other point I want you to graph is 1, 7.
Is that a Y or a 4?
That's a 4.
I can't tell.
It's a -3, 4 and a 1, 7.
Right.
So I want to know, what is the slope of this line? Does anybody remember how to find slope? Yeah.
You have to subtract y2 minus y1 and x2 minus x1.
Yes. Did you guys do y2 minus y1 over x2 minus x1? Does this look familiar at all?
Kind of.
Yeah? Okay. Now there's a couple different ways you could think about it. You can think about it like this formula. You can think about it as rise over run. Heard of that before?
Yeah.
How far it goes up and how far it goes over. Now, on an example that is a graph like this, it's actually pretty easy to see. How far up does it go from 4 to 7? So it's going up 3. And then how far does it go over from -3 to 1? 4. -3 is 3 on this side, and then 1 on that side on the positive side, so that's a distance of 4. So it goes up 3 over 4, which is 3 over 4. If we did the x1, y1, x2, y2 thing, does anybody care which one we call x1 and y1?
No.
Okay, I'm going to call this one x1 and y1. And they're both called 1s because they're both the first point. Kaden, you have to write. You've got all this? Sweet. x1 and y1. This one is x2 and y2. Why is it called 2? It's just the second point. And by the way, you could have called this one the first point and this one the second one. It doesn't matter. Okay? As long as this one is x1 and y1 and they're both 1s or they're both 2s. That's important. You can't have like x1 and y2. They're both either 1s or they're 2s. And if I plug them in over here, let's see, y2 is 7 minus y1 is 4. On the bottom is 1 minus x1 is -3. What's 7 minus 4? 3. 1 minus a -3, dash, dash, slash, slash, +4, 3/4. So you see how it doesn't matter if you think about it like a graph and you think about, ooh, rise up 3 over 4, or you think about the y2 minus y1, x2 minus x1 thing, and then do the math that way. Either way, it works out exactly the same. So it depends on what you're more comfortable with. Example 2. This time, the points are going to be negative 1, 3, and 4, 1. Okay, now I want you to turn to your partner right now, and what you're going to decide together is, are you going to choose to do this with a graph and rise over run, or do you want to do this with the y2 minus y1 over x2 minus x1 formula? Is it going to be a formula, or will it be a graph? You guys decide together. The answer to this is going to be negative 2/5. So go ahead and try it with your partner right now in whichever way you decided. You could do it with a graph. You can do it with a formula, whichever way you want. If you're both stuck, call me over and I'll help. Stuck? Which way do you want to do it? The graph way or the formula? Okay, so then you have to pick one of the points to be x1 and y1. Okay, so right, x1, y1. And then this one would make x2 and y2. This would be negative 1 minus 1. What is that first number in a coordinate is always the x. The second one is always. No, why don't you go grab a calculator? You're welcome to grab a calculator right now.
No, we're good.
So now plug in y2.
Yeah, so you start with y2, which is
Did that work together at all?
well, we said that's not matter if this was x2 and y. These you better carry x1.
Okay, so here's that. Okay, first I'm going to write it. Okay, but is it you decide on the same method?
Like the x and get y that are the same. You have to do the same amount and you have to x1 here. And now, the first number is there's always x. Second number is always y. Just negative 1. So they're always labeled 3 minus 4 x. No, because it's 3 minus negative 1, right? Because we're doing because we took 1 minus 3 should be we got negative. The top would be 3 minus, and then it was 4 minus negative 1. Good. Y dash x. Oh, that is 4 plus 1. You can write it down. You good? You guys trying to do the up and down? So how far does it go up and down from? Yeah, 4 minus negative 1. Right, negative 2. That's the rise. Drop. Negative 2. Yes. And then how far does it go?
You guys don't want to go up?
Yes, I will. Yes.
No, we gotta do Where's the 5 here? All right, here we go. I am looking for 2 partners who would like to come up here and show me how to do this problem. I don't care if you do it with a graph or if you do it with formula. Check in with your partner. Decide if you want to raise your hand. Hands up. 1, 2, 3, 4. One.
It's always Cooper. Every single time.
No, it is always me when I don't want to go up there. But I made a deal with my partner.
All right. Did you guys do it with a graph, or did you guys do it with?
We did it with a graph.
Okay, sweet. Show us the graph one. You
All right.
have lots more opportunities.
Alright, so you gotta draw your graph with that x going up to at least 3 and your y going to at least 4 and -1.
Is this good, Jackson? Looking pretty good. Pretty spazzy.
So yeah, put your marks down for x going -1 to 4,
Wait. What are we doing?
the marks
Oh. Where are we putting those?
On the line.
on that
Yeah, but
x line.
the X?
Saying you need one at -1, and then going to 4 the other direction. Tallies, like doing those dashes. Yeah. 2, 3, 4. Good job.
And then
Yeah.
on your y, you need them going up to 3.
Okay.
And then
Sweet.
you're gonna put a mark at -1, 3.
-1, 3. It's up here, right?
Mm-hmm.
Sweet.
And then a mark at 4, 1. And then draw a line connecting them. And then you're going to count the amount of spaces
You're going down,
over
right?
and down that it takes. So it should take 2 down.
Mm-hmm.
5 over.
2, 3, 4, 5.
And then you get your fraction 2 over 5
Why is it negative?
because the slope's going down.
Yes. So if the slope goes downhill, left to right, it's a negative slope, and if it goes uphill, all right, everybody got distracted because somebody was going through the door. Look at my hands. Look at this. Whoa. Okay, here, this is downhill, negative, uphill, positive. Go grab Floyd. Right, these guys. Very nice.
What are these things?
Mm-hmm. You can take a pair. They stick to stuff. Put it on your mom's toilet.
Kid Classic, I'm a winner sign. Why not?
Classic. All right, example 3. Example 3, I want to go back to looking at tables. So here we go. So another word for slope is rate of change. So slope is the same thing as rate of change. So usually the rate of change has a 1 on the bottom. So let's say we found out that to get 4.75 gallons, it costs you $15.77. And to get 6 gallons, it costs $19.92. To get 7.25 gallons, it's $24.07. And then 8.5 gallons is $28.22. Okay. So how do I find out the rate of change in this situation? How do I find the slope? Any ideas? What were you saying? Cost over gallons. Yeah, how the cost changes versus how the gallons change. So this is going to be the change in y over the change in x, which is the same thing as rise over run. We've got to pick 2 points. I'm going to call this one x1 and y1 over here. This one x2 and y2 over here. And I'm going to do y2 minus y1 over x2 minus x1. By the way, it doesn't matter if the 2's or the 1's go first, as long as it is the same point. Also, how did I know to pick the top 2 points? It doesn't matter. I can pick any 2 points I want to. I can pick the bottom 2, I can pick the top 1 and the bottom 1. Doesn't matter. Okay? All right, so what should I write right here? What's y2? 19.92 minus 1577 divided by 6 minus. Nice job. All right. Put those in your calculator, please. If you don't have a calculator, go get one. Do I like snow? Oh, I love snow. I don't like driving in a snowstorm. Besides that, love every bit of snow. Every part about it. Oh, I had a snowball fight with my kids this weekend. All right. You should have gotten 4.15 over 1.25. Do you guys get the same thing as I did?
Yeah. Oh, I got 19.
Did you do a 6 minus first? Boys,
No, I did it.
we're working on this now.
It was given out fish, I dropped it. Oh, I should test it.
Okay. But what does this mean? What is this problem about? Caden, what's this problem about? It's up here. Cost of what? Of? Yes. So this, it costs $4.15 for 1.25 gallons, which is super unhelpful. Because nobody cares about how much 1.25 gallons is. What do they want to know? 1 gallon. How much 1 gallon is. And if you divide these two, you'll find that.
What's gas prices nowadays?
Did you guys get $3.33 per gallon? Make sure you write it out like a full story problem. Now, one thing that you might be asking yourself right now is, why didn't we just take the cost per gallon and divide by the gallons in the first place? Go ahead and try it. Everybody take 1577 in their calculator. Type in 1577. And divide by 4.75. $332, right? So why would we do all this mess? Just to figure that out. Okay, let me explain why. If it is something that you are certain that if you get 0 of it, that it is 0 in return, that 1 point is 0, 0. For example, if I go buy 0 gallons of gas at Quick Trip, how much does it cost me? $0. That's a 0, 0. Then you can just divide the two, and then that'll get you your unit rate, and you'll be done. But you know how sometimes it's like they charge you a certain fee, and then they charge you an additional fee per hour or something like that? That wouldn't start at 0, 0, and then it wouldn't work. This way will always work with every single problem. But if you can think about the problem itself and think, if 0, 0 was here, would that work in this situation? And this one it would, right? Because $0 for 0 gallons. So you could just divide them on that one. Okay, we're almost done. Example 4. Sure. All right, example 4. It is important this time that you label. So this is the x-axis, this is the y-axis, and this is my line. It's like a flat line at -2. Just make sure your graph looks like mine. This is a horizontal line. Write it down, please. A horizontal line means that it's flat. What's the slope of a flat line? Huh? 0, 2? Are you saying like 0, 2 is one of the points that's on here? Or are you saying that the 0 TOO, like it's also 0? Oh, the point. Okay, so you're saying that it would, like, let's say we pick this one. I'm going to pick one that works with your situation. Let's say we pick this one and this one. This one, the point is 2, -2, right? And this one is 0, -2. So what you're saying is that when it goes up and down, it doesn't change at all. But then maybe it's over 2, maybe it's over like 4. If we wanted to, we could just pick 2 points on that line anywhere. But no matter what, the top would be 0. And 0 divided by anything is 0. A horizontal line always has a slope of 0. Always. You don't even have to do math. Horizontal line has a slope of 0. I'm going to write slope by this. By the way, if I was going to write an equation for this line, I would write y equals just -2. It's just always -2. Always -2. Example 5, last one. What do you think I'm doing this time? A vertical line, yep. I'm going to go over to, I don't know, 4. Make a vertical line up and down. This is a vertical line. Horizontal line goes left and right. A vertical line goes up and down. All right, let's pick 2 points this time. Let's see, this one is 4, 4, and this one is 4, 1. Okay, so between these 2 points, how far does it rise? From 1 to 4, how far does it rise? 3. And how far does it go over? 0. Not at all. Can you divide by 0? Can't divide by 0. So this answer is not possible. There is no slope. No slope on a vertical line. And you can't say that's the same thing as 0. 0 is not the same thing as not possible. Tomorrow, I'm going to do one more example with you for your homework. And then I'll give you a homework day. All right, so your homework is page 225, 1, 2, and 5, 23 through 31, 38 through 41, and 50 through 52. All right, I want to show you guys a quick demonstration before we go today. For this, you can just look up at me. Escape. You don't have to write anything down. Escape.